So here we are going to discuss about procedure or operation, how SRVCC works. And in this case, we will take an example for an operation assuming that both packet switch and voice data both are running on LTE, and what would happen if UE goes into bad coverage of LTE, and how SRVCC is going to transfer the call from LTE towards UMTS or UTRAN in this case. Now, just like in any handover, there are two phases. In this case, I've divided it into two phases, phase 1 and phase 2. So the first phase is about the setting up of the preparation requirements, meaning before the actual session transfers takes place for both voice and data, what should be the signaling requirements in terms of the back end. The front end needs to take place before the actual session transfer will take place. So that will done in phase 1, and actual session transfers and sessions deletions will take place in phase 2, which you will see in here in a little bit. So let's get started here. The first thing you need to understand is, as you know, in case of any handover in LTE, there needs to be an event to take place. So in this case, if UE is going in bad coverage, event A2 needs to take place, and UE is going to send a measurement report, as you can see over here in the screen. Once the measurement report is received, it's up to the E node B to decide either handover decision, meaning handover needs to take place or not. So in this case, if E node B knows, the serving E node B knows that its coverage is going bad for the user, then it's up to his decision, either SRVCC procedure needs to take place or not. Assuming, let's say, if E node B decides that SRV procedure needs to take place, then it has to identify the target RNC and the node B where UE will eventually go and do handover. And if that is the case, we are assuming this is the case in this scenario, so it is going to send a request to MME. Now telling the MME that the handover is required on S1 AP using S1 AP protocol over S1 interface. Now this particular handover required message does not contain only this information, it also contains the handover type, meaning telling the MME that SRVCC is going to use UMTS WCDMA as a radio access technology. It will also include in this message the target ID of the RNC over which the handover needs to take place, or plus the location, area identity, and other related information. It is also going to indicate in this message the handover type, SRVCC handover type, meaning is it just a packet switch portion of the handover, or is it the circuit switch, or both are going to take place. Once this particular message is received by the MME, it is going to divide or split that message into two portions, meaning assuming packet switch and circuit switch, because it has to send the required portion or request towards the respective parties in this case, which will be for circuit switch. Let's start first of all with circuit switching. So in this case, MME will forward a request towards media gateway or MSC server, and it will send this request, which you see over here is termed as packet switch to circuit switch request. Once this request is received by MSC server, also abbreviated as MGW, it is going to forward the same request towards MSC, which is the target MSC in this case. Now target MSC is going to ask or inquire the target RNC, meaning to find out if target RNC is ready to take that particular handover request or not. Let's say if the target RNC does agree to it, to this relocation request, then it is going to send an acknowledgement. However, before that particular request acknowledgement happens, as you know, our original request consisted of data and voice portion both. So for the data portion, MME will forward that request towards SGSN, and the arrow already ran. Let me run it again. MME is forwarding this request towards SGSN, and this is the same relocation request, meaning the session needs to be relocated. Once this relocation request is received by SGSN, it will forward it towards target RNC once again. So target RNC is going to make the decision for both of these requests, circuit switch and packet switch both, and it will send a response, which you can see as relocation acknowledgement going towards SGSN, and then this response or acknowledgement is going all the way back towards MME, right, which you see forward relocation response has been received by MME. That being said, what about the circuit switch portion? You can see RNC is giving the request towards MSC, which is the target MSC, and target MSC is going to forward that acknowledgement all the way back towards MSC server. So this is the prepare handover response. Once this response has been received by MSC server, circuit has been established, meaning the signaling flow has been established here. Now remember, before this response is forwarded towards the MME to inform MME that the circuit switch portion for voice has been established, this MSC server or MGW media gateway has to inform IMS as well, so that IMS can get ready to transfer its session, meaning IMS has to transfer the session from LT towards UMTS side in this case. Once this request is sent, then media gateway is sending this response all the way towards MME. This response is packet switch to circuit switch response, which is for the initial request which was sent. As you can see over here, packet switch to circuit switch request which was sent. Once MME receives this response, it is going to forward this handover response back towards eNode B, and eNode B finally is going to be happy and it will send this message towards the UE, and it will send a command towards the UE to go and do handover, which is basically a mobility information command towards the UE, which simply means that UE should go and get itself tuned towards the UMTS. Now, while that being done, what about the IMS? In the meantime, IMS is getting ready to transfer that session, as I mentioned, and update its remote leg, and also it is getting ready to release the IMS access leg for the session which is running with the LT towards the, it should remove or release the IMS access leg from LT and transfer it towards the UMTS side. So that is phase one. What about phase two? In phase two, things will happen pretty quickly. UE is going to tune towards the UMTS or UTRAN, and once it gets tuned, then target RNC is going to inform to the MSC, in this case as you can see with the arrow, that relocation has been detected. Once relocation has been detected, it is going to inform the same message to SGSN as well. As you can see, the arrow is going towards SGSN for the packet switch portion, and then handover complete will take place towards the target RNC. As you can see, this green arrow which is going towards the target RNC, which simply indicates that handover to UE has been completed, or handover of the UE towards the target RNC has been completed. With that being said, then target RNC is going to send a response for relocation complete towards MSC, and then MSC is going to forward this towards media gateway or MSC server, indicating handover has been completed. And also this answer message which you see over here, this answer message, this is nothing but this is just acknowledgement. It does not contain any contents in this message. So this response is going to be forwarded towards MME. Once MME will receive this complete notification, it will send an acknowledgement, and with the acknowledgement it is going to delete the bearer for a voice session which was going through. Now we have packet switch as well as the circuit switch, meaning the voice and the data bearer. So the bearer will be deleted. Now we still have the packet session which is running. So for that, MME will forward that acknowledgement towards the SGSN. As you can see over here, before MME sends an acknowledgement, the target RNC is informing SGSN, if you see on the bottom left, that relocation complete has happened, and MME is forwarding the relocation complete message towards SGSN. As a result of this forward relocation complete message, SGSN is going to send a confirmation or an acknowledgement which you see over here. Once this acknowledgement is received by MME, then MME is going to delete the session. Before the session is deleted, PGW, you are going to update the bearers for the packet switch session to be updated. And once that is done, MME is going to delete the overall session which was going between MME and PGW for the UE, since now UE is connected towards UTRAN or UMTS. With that being said, MME is going to release any resources, and it will also command eNode B to release any resources. And once those resources are released and sessions are deleted, your UE is now connected towards the UTRAN. So the bearers are deleted, and this is the final picture which you see happen or take place. So this is how, in case of SRVCC, seamlessly UE is handed over from your LTE towards 2G or 3G. In this case, we discussed the scenario for 3G specifically, and we considered both packet switch and voice sessions together being transferred. Depending on what feature or what specific feature you guys are using in the field, the signaling flow could be different. This is the general information when the session is transferred, and this is how the final picture should look like. In case if you have any questions about the signaling flow or comments, you can always write the comments below. Thank you.